Okay. We'll call this question a complex factoring question. There are four terms here. Now, if this was a polynomial that had one variable in it, then there would be a whole different style of factoring. We'd use something called like synthetic division or polynomial division. But we actually have two different variables in this question. So the question then becomes, how do we tackle this? First of all, let's look at our y's. There's only one term that has a y variable. So it makes it hard to pair up in like common factor or set with a constant. This two together, I mean, if I rearrange them, okay, I'm going to use an if statement here and say, if I rearrange these, I actually get 25 and negative y squared. And then I get positive x squared and negative 10. Oops, let's give myself a little room there. And negative 10x. The ones I've written in red, I don't know if you noticed, those are a difference of squares. I could get like negative 5 minus y, 5 plus y. And then these two terms here, I can factor out an x. I know that's really hard to read. It says 10x. It says x squared minus 10x. I could factor out x, so I get plus x. I think x minus 10. That is a style of factoring. I mean, I have some factoring there. I can't go any farther. But if I spend a little more time at this, I can actually take a look and I go, actually, I can get a trinomial here. I'm going to do a little rearranging. We'll put it in alphabetical order. We'll go x squared minus 10x. And I'm going to put the constant term here and then just have the negative y squared at the end. I'm going to look at this as a trinomial in itself. Okay, so can I factor this piece? I'll do a little fearless factoring here. 5 and 5, 1 and 25. Two products got to make 10. Well, if I go 5x, 5x, I get 10x, which means I did this column. I know I did that really quickly. But those are our two factors here. So in terms of my trinomial, I get an x and an x. And then we did x times 5, x times 5. So the positive 5 goes in the end of each bracket. Okay? And then I still have to keep my negative y squared. Well, if I take a look at these two these two factors here, I can represent them as a single one. X plus 5 squared minus y squared. That looks like it could be done, but I can actually simplify a little. Why don't I say let a equal x plus 5. When I do that, I end up with a very neat scenario. I get a squared minus y squared. Similar to what we were talking about before, way up here when we showed the 25 and the negative y squared. I get a difference of squares again. So I can use my quick difference of squares. I square root a squared to give me a. I square root y squared to give me y. So a is the first term in each bracket. Y is the second term in each bracket, and I just put a plus and a minus in there. There we go. I'm technically factored. The only problem is there wasn't an a in my original question. So I got to reuse that let statement. Let a equals x plus 5 once again. Show my reader that I'm plugging it back in. So now in my bracket, I get x plus 5 plus y. And we get x plus 5 minus y. I'm going to collect like terms, which there aren't any. So I'm actually just going to rewrite it in an order. I'm just going to go x plus y plus 5. And this becomes x minus y plus 5. This is one you can test. You can technically take the x, multiply it by all 3, then take the y, multiply it by all 3, and then take the 5, multiply it by all 3, collect your like terms, and you'll end up with what we have at the top. That's a lot of extra work. It's another very long algorithm to do that. But this would be the style of factoring. So it takes a bit to recognize something like this. That, I went down a route and I said, I did some factoring, but may not be what they're looking for. I put it into a trinomial. Turned out it was a perfect square trinomial. Because it was a perfect square trinomial, I can then use a difference of squares. I went through the difference of squares. Then I substituted back in because I made it a little simpler. And I finally ended up with not a binomial, so this would be like binomials with 2 terms in each bracket, but there's trinomial, there's 3 terms in each bracket. So a little harder in terms of what it is I needed to factor in that question.